It's very slow. That's part of the illness, I think. Okay. All right. I'm okay now. So, are we live? We are
Yeah.
recording, and I think we're live. Okay, get going. Hi, I'm Metta Spencer. Today, we get to go someplace where, as a program, we have never gone before. I have never yet, until today, been able to run a forum in which one of the speakers is in China. But today's the day. And it's going to be fun because we're also going to be talking about a topic that is, I'm sorry to say, news to us. You know, I've been doing these shows about, if you'll pardon the expression, geoengineering for about, I don't know, 6 months. And I've been talking with people about all kinds of interventions and proposals for how we can cool the planet. And I sometimes even use the word geoengineering because people advise me not to use that word because it puts people off. So if you're listening, you can, pretend I didn't say it. But anyway, when I talk about geoengineering, we've been covering all kinds of topics. How do we get rid of methane and how to get rid of CO2 and how to reflect light and things like that. But the one thing that people I almost always identify with geoengineering is a phenomenon which is, the abbreviation is SAI. It stands for stratospheric aerosol injection. And basically, that may be the only thing you've ever heard of when you have heard about geoengineering, because it's a proposal that planes or balloons or pipes or something will deliver large, reasonable amounts of sulfur or some other product into the stratosphere, and that this will reflect light away from the earth so that it doesn't penetrate and come down and warm us up. So that has been the most popular or the most widespread assumption about what geoengineering is. And yet, even though I've talked about every other kind of a proposal, I haven't got around to talking about SAI in all this time. So we're going to make up for that today. We have 4 people here who have opinions about SAI, and I don't know that they necessarily agree. So if they agree, that's fine. But if they don't agree, let's hear why. In near Bristol, near Bath or someplace in UK is John Nissen, who's very active in this thing called the HPAC, Healthy Planet Action Coalition. The same also for Herb Simmons, who's very active in that, and he is near Washington, D.C. today. And Itao is our friend who is not really involved with SAI, I think. And he is in, I believe, Beijing. Are you not, Itao?
Right now I'm in the south of China, a province called the Yunnan province.
Oh,
Uh, it's where all the hippies go.
hippies go. You have Chinese hippies.
Well,
How
mostly
did,
Western actually, but they find
oh,
certain remote villages
yeah,
quite suitable. I mean, it's very close to India and Nepal, and
really?
Tibet. So it
Didn't
has
know
similar
that.
vibes.
No, I hadn't. I think it's been 30 years since I was in China, but I didn't know that. And I don't think I looked much like a hippie in those days. So anyway, and Yatao is the head of and maybe founder and the chief cheerleader for something called MEER, MEER, which we're going to talk about in a bit. I don't know, the acronyms somehow stands for mirrors. And he can explain in a minute, but it's a proposal that we're going to reflect light away from the earth by just putting mirrors on top of our houses, as I understand it. And maybe I've got it wrong, but he'll correct me in a minute. but his assistant or I don't know, administrative assistant or something is Kathy Posey. And Kathy, unmute yourself and say a little bit about who you are and where you are.
Hi, as you said, I work with Dr. Tao. I've been volunteering for MIRRS for Earth's Energy Rebalancing for about a year now. And I currently reside in the Marshall Islands. So I'm out in the middle of the Pacific in one of the low-lying atolls. I'm on Majuro.
Again, this is a double new experience for us because I'm almost sure we've never broadcast from or involving people in the Marshall Islands either. So we are really global today. And thank you for being with us. And chime in whenever you have some thought that you want to. That's true for everybody. It can be a free-for-all, interrupt each other and whatever. Okay, now I don't know where to start here, but I would like somebody to give as dispassionate as possible a brief introduction. I'll ask Herb to do it because I've been told that John and Ye do not necessarily agree, and Herb may be sort of a neutral character. So Herb, will you give us a 1-minute synopsis of what SAI is and why it's considered controversial?
Thank you, Meta, and thank you for inviting me today. I don't know if I'll be able to please either John or Ye or anyone else with what I have to say, but since you've just given me a minute, I'll be as quick and as succinct as I can. As you indicated, it stands for stratospheric aerosol injection, which basically, as the term suggests, it means injecting particles. As you said, sulfur is usually what's most described frequently, but it doesn't have to be, into the stratosphere, because in the stratosphere, there's sort of a planetary circulation that could result from any particles being injected into that area. And sulfur has the ability to reflect sunlight. I may not be saying that scientifically accurate. I'm not a scientist, but essentially, I guess and it is very controversial because it is large-scale intervention into the Earth's climate.
It's some kind of sulfur compound. Is it oxide or?
The sulfur dioxide.
Dioxide, thank you.
Yes.
Is it a gas or a solid or what kind of a critter is it?
It's a gas.
Okay. Okay.
And it's about the same weight as CO2, so they kind of mix up in the atmosphere. It's not heavy enough to sink or light enough to rise.
Okay, now, Herb, I interrupted you. Go, sorry.
Yeah, no, I was going to say that, I mean, it's controversial, because it's direct intervention into the climate, which has never been done explicitly because of its large scale and significant impacts. And there would be no reason to do it if it didn't have a significant impact, i.e., lowering global temperatures by a significant amount, depending upon how much is put in, where it's put in, when it's put in, et cetera, et cetera. And it conjures up, the images basically of people, in many cases, it's perceived as a small group of people, usually white, rich from the northern hemispheres, who want to basically control, the sort of the climate dial for everybody on the planet. And so it's understandably very controversial for that reason and for many other reasons as well. And the last thing I'll say is that it's though the idea has been around for a long time, it has gotten a significant boost from looking at the consequences of the eruption of Mount Pinatubo in the Philippines. I believe that was 1991, give or take, which led to what appears to be a decrease in temperatures for a year or so, maybe longer, of around 1 degree C, give or take, without any, terribly deleterious consequences from that. So that's sort of like a natural experiment So the feeling is if we could, rather than relying on sort of keeping our fingers crossed that the right volcanoes will go off at the right times in the right places, the simple idea is why don't we do that as humanity to try to mimic the results from that volcano in a controlled, safe manner. So I'll stop there.
Okay, thank you. That's a perfect introduction. Let's talk about the pros and cons, or any other qualifications. I don't know, since I have an idea that you two, Ye and John, are somehow take different points of view, but I don't intend for this to be a debate. I like to look for common ground instead of exacerbating any disagreements. But let's see, John, maybe I'll give you the floor first, and then of course Ye can interrupt anytime the impulse occurs.
Yes, well, it's one of the great things about a stratospheric aerosol injection of SO2 is that the SO2 is a gas, and it has it will form little aerosol droplets with the moisture in the stratosphere, and that is highly reflective, and so you can reduce the amount of sunlight which reaches the Earth, and it's a bit like turning down the solar power onto the Earth, turning down the sunshine a bit. So it's like a very thin veil of sunshade, and it would one might put enough to reduce the sun by 1 or 2%, and that should be enough to produce a huge amount of cooling beneath where the sulfur is sulfur dioxide has spread. And the aerosol spreads can be expected to spread very thinly over a very large area, because there are winds in the stratosphere eastward flowing around the planet, and there's also a northward component in the northern hemisphere, in the southern hemisphere. So when you inject at a mid latitude, say 40 or 50 degrees north, the sulfur dioxide will tend to drift northwards and spread out, and that can produce quite a uniform cooling effect, which is really what you want, because if you produce your cooling in one particular place, you could affect a particular weather system, and then you might affect it adversely, and then people would complain that you're modifying the weather in the wrong direction, and perhaps sue you for doing it. So the fact that it spreads out evenly quite quickly is a real important advantage of it. And so
I'm sorry, why? Why does it matter if I mean, suppose it's stuck together in a clump. What would be bad about that?
Well, you just get the cooling in one place, and then if that's not the optimum place,
but wait, the stratosphere moves. The Earth is moving. I get now. Here's how dumb I am. Is it the stratosphere stays still and the Earth rotates under it?
No.
Or does the stratosphere move around with the Earth?
Yes, it does.
So
but-
it would,
but it does have-
so if you had one big clump of this stuff, there'd be just a spot underneath and it would still say the same spot as it moved. Okay, all
Yeah.
right, I'll buy that. It's very basic
Yeah.
things that I have to ask because
Yeah.
I'm not, gifted in these matters.
So that's considered a major advantage of stratospheric aerosol injection. There are a lot. The other places, the other ways of doing it, tend to produce local cooling, whereas the stratospheric aerosol can produce a very broad brush cooling and bring down temperatures everywhere, and not modify particular weather systems, just have a very general cooling effect. So that's kind of advantage of it.
Mm.
Another advantage is it's very scalable. So you can just put up more SO2 and you get greater cooling proportionately. And there's not considered really any practical limit to that. Although no doubt at some point one would run out of SO2 to put up there, but it's a very common substance which results from oil refining, and if you can remove sulfur from burning coal.
Mhm.
So that's not considered a limitation.
Okay,
Uh,
my guess is
so-
that really you and Ye have something in common in that both of the technologies that you're promoting, and I'm jumping ahead and reading what I
Mm.
think is Ye's mind, but I'm not sure that I've got it right. But both of you are really into the process of reflecting sunshine back into space, as opposed to the business of removing methane or CO2 from the atmosphere. That the benefits that you hope to accomplish both come from the same mechanism, reflecting sunshine rather than removing CO2, which is the basic cause of global warming, right? Am I wrong?
Yes, so you can divide the global warming problem into two. The planet is being heated because there's too much sunlight being absorbed, and there's not enough thermal radiation escaping from the Earth. So thermal radiation is when a body heats up, it radiates. It's called black body radiation, but it's thermal, also known as infrared or long wavelength radiation. So there's a kind of technical terms for it. And the clouds and CO2 and so-called greenhouse gases all have a blanket effect of dampening the amount of thermal radiation out into space, and that causes the temperatures to rise because there's less thermal energy escaping into space. Now, the other side of the equation is the short wave, the sunlight, visible radiation, and that is there's not enough being reflected. So the amount reflected from the Earth has been reducing. And that's because one of the major reasons is there's less snow and ice reflecting the sun.
Mhm. Okay. Well, let's see what the critics say. Why would anybody, apart from just the general reluctance to go mucking about with what God created, what would be the scientific objections to doing this because of a concern about harmful side effects? I need more from the fridge. Sorry, what's going on here, I'll edit this out. There's a nurse who comes every day and makes me take pills and injections. And she's come in here and I had to open a new package and she's got to go get more stuff out of the fridge for me. And it turns out it's very disruptive, but I promise I'll remove as much of this disturbance as I can. Anyway.
Well, perhaps we could take this as regarding the health of the planet. We need some cooling medicine, basically. And there are two ways of cooling the planet, basically. One is to let more thermal energy out from the planet when it heats so that it doesn't heat so quickly. And the other is to provide a sunshade and reduce the amount of sunshine reaching the planet.
Mm-hmm.
And
no, but it doesn't really solve the basic problem, does it?
Well, you have to do both to restore the Earth back to the energy balance and the temperatures.
Does everybody agree that you have to do both? If you say they have to do both, but is it possible that some people will say, no, all you need to do is remove CO2 and methane or whatever from the atmosphere?
Right, yay.
Yes.
Maybe I can chime in now.
Yeah, chime in.
So MIR is also part of HPAC, and actually all of us recently co-authored a paper pointing out the necessity for direct cooling interventions as part of the solution. So there's a lot that unites John, myself, and Herb. And there's the difference between us is minor compared to the difference between our view with the randomly selected person from the general public. So I just want to make that clear. With that said, I think it's very sad that the term geoengineering has been associated with the direct cooling, because I think we are very far from being able to engineer the climate, because we understand very little of all the different systems on planet Earth. A much more appropriate term is probably geo-experiment, one of which we have conducted that involves burning fossil fuels. And even the carbon cycle itself, we currently do not fully understand. We cannot really predict with high precision the response of the carbon cycle to the warming that's induced by the carbon injection itself. So even without deliberate geo experiment, we cannot really understand. We don't understand what's going on with the current ongoing experiment. So I think my concern, my background is coming from the experimental scientist background, and my experience in the field is only about 10 years or less. Previously, I was doing high precision metrology at low temperatures, making sensors to do very precision measurements. And since I joined the climate field, I have been rather surprised to gradually learn that the precision of some very fundamental measurements on planet Earth is seriously lacking. We have only on the order of 10,000 weather stations that's somewhat well calibrated, scattered around the globe. And that gives a density of more or less one measurement station for every 100 by 100 kilometers. So it's a very huge piece of land where we have very sparse sampling of real in situ data. So this under measurement of planet Earth has led to models not having very precise constraints to work off of, to really check whether our climate models are faithful representations of planet Earth. And in all the scientific fields, or most of them, with the exception of maybe geoengineering, the proper way to conduct experiments is to construct an apparatus, make a sample with the actual materials you're studying, put that into precision instruments that you calibrate to precision much better than 0.1%, and then measure the empirical results and try to interpret the empirical measurement using best theories you have. Sometimes it's useful to invoke computer models as a way to try to understand the underlying mechanisms which are not resolvable by your measurements. Unfortunately, this is not how climate science has progressed, because in part because of this problem of insufficient measurement to constrain the models. And another
Right, but
problem
excuse
is
me,
that
but, yeah, but when you were doing work as developing technologies for monitoring and measuring, was that the kind of measuring devices that you were trying to develop? Was it relevant to what you're doing now or not?
yes, it's physics is physics. So there is a radiation, heat transfer, convection, electrical capacitance, magnetics. So it's a very common set of tools that you use to engineer different devices to act as what's called transducers. So one example is, how can I say? Okay, let's imagine you're in a swimming pool, and you're standing underneath the diving board. Just by looking at the diving board moving, you can infer that there is a person on top of it.
Mhm.
So the diving board is motion. By observing its motion indirectly, you can infer something about the actual physics happening in the system. So the same thing happens in the measurement of temperature. So one can use something called a thermocouple. Basically, it's a junction between two dissimilar metals, and you can measure very small voltage across it, which is a function of the temperature in which this junction is based into. And then just by looking at the voltage of the leads, which can be very far apart from your location of measurement, you can then infer through this voltage phenomena what's one of the properties of your zone of investigation. So that junction, that thermocouple is acting as a transducer. So it's a very similar set of techniques that's used regardless of the center type.
If force into practical terms, what technological decisions that are up for discussion and can be made now would be determined or affected by discovering more facts from these monitoring devices, these measuring devices.
Okay, so that might be
What is it we
very
don't
specific.
know that we need
Okay.
to know in order
Yes.
to be reasonable, and that
Okay.
your gadgets can help us do?
I'll go into the example of specific to energy rebalancing. So the reason why planet Earth is warming is because we're receiving more energy from the sun than we're able to get rid of through infrared radiation. And we can measure this quantity in several ways. One is by really having satellites orbiting the planet Earth and taking snapshots of different locations, and to measure how much light is coming in, which is the energy that's inputting into our system, and also counting how much infrared radiation is going out, which is the spending, the expenditure. And then when you take the difference between the two, you get the net amount of energy that's either stored into or taken out of the system. So that's one way to do it. Another way is to look at ocean temperature change. But I will come to the first method of satellite-based measurement. So just to give people a sense of the magnitude. So incoming solar radiation happens on the order of 340 watts per meter squared. And outgoing IR radiation is 39 watts per meter squared. And the difference is minute. The difference currently that's driving global warming is 0.03% of what's coming and going. So imagine you're counting people. And for every maybe 340 people you're counting coming in, you count 339 people coming out. If you just lost your attention for a split second, you miscounted one or two, then in the end, you get very different results, either +1 or -1 or 0. But that 1, -1, or 0 is the difference between going to global cooling at 0.3 degree per decade to a warming of 0.3 degrees per decade. So it matters really a lot how precisely we can measure this energy imbalance. Unfortunately, the satellite that's doing these measurements, for instance, in the Aquaterra satellite, the Ceres project, they have say, shortwave measurement uncertainty, basically how precisely they can measure sunlight, the uncertainty is about 1%, meaning that for every 300 people they count, they will miscount 3 on average. Sometimes they count more, sometimes they count less. So it takes a long time to average. So they have to count each location several times around. They pass by each location once a day or twice a day. So they have to pass by 7 or 10 days in order for this error to be reduced down by averaging to something that's acceptable. But this need for really taking long duration measurements is really against the geo experiment. Because it's an experiment, which can have negative consequences, we need to be able to detect the signal or the effect of the intervention as soon as possible, so that both the driver for the system or the arbiter that says, okay, that's enough harm, they need to be able to update it in a timely fashion. So our inability to perform such measurements in any timely manner is one thing that hinders a proper evaluation, scientific evaluation of these geo experiments.
I see.
So
And
especially
you were making some gadgets that would do a better job of measuring these minute differences, and you're not doing that anymore. Is that right?
no, the sort of gadgets we're making minute precision measurement for force. It's a different physical phenomenon, but we haven't really moved into. We only start to move into making better environmental sensors, but we come from a bottom-up approach. And the reason of that, I will explain now. So John pointed out really nicely that one purported advantage of the SAI is that you have the spreading out the particle all over the globe to have this uniform coat. The disadvantage of that from a measurement point of view is for any specific location, you have a relatively low local radiative balancing impact. So basically you're adding 1 or half a person to this field of view that the sensor is counting. So it makes the averaging all that much more difficult. So as a way to solve that problem, our approach from the ground, at least from experimental point of view, is much more amenable. Because let's say if you were to block out all light over your living room, you would measure that the room would get cooler by several degrees, up to 10 degrees Fahrenheit, very easily 5 degrees Celsius, cooler every single day. So you can measure that even with a mercury bulb thermometer. The reason why you can measure that is locally, you're having a much 100% or 10% perturbation to the solar radiation flux, compared to if you were doing it up high, diffuse fashion, they have much less signal. So from a experimental point of view of trying to understand what is or what are the downstream global circulation impacts of radiation balance modification for planet Earth, there's an advantage in starting to implement these highly intensive cooling on the local scale, for which you can install very sensitive sensors at high spatial density to really have a very nice high-resolution movie of how the temperature field evolved in time as a function of your perturbation. And then it's also conceivable to have advanced atmospheric circulation monitoring devices such as LiDAR and wind radars to track how this local cooling perturbs the local microscale circulation of air. So microscale meaning between sub-meter to about 2 kilometers. And this is the foundation to understanding.
Let me see if I can guess. I think my guess is what you're driving at is you want to have, in some cases, experimental data from that affect local cooling, and that the way you want to do it is with your mirrors. Is that what I'm just playing with you to see whether I'm guessing. Is that what you're driving at?
The cooling can be induced in multiple fashions, of which mirror, which acts on visible light, is only one of them. Okay. There's a burgeoning field in material science research that's using different kind of materials and structures and fabric that are able to selectively emit heat as IR radiation that do not interact with CO2 or water vapor, so that the heat that they radiate is able to penetrate through the atmosphere directly into space. between
Wait a
thermal
minute. Oh, hold on.
wavelengths.
Yeah, why would you be trying to measure heat? You'd create heat, what? You'd do a satellite and create some heat to see if you could penetrate the atmosphere from above?
No, so
I'm
as John mentioned, explained very nicely, there's two ways to cool. One way is to reduce how much heat you take in.
right.
That's accomplished by reflecting away sunlight, which is the source of heat for planet Earth. The second way is to encourage the heat leaving as quickly as possible. The heat that's already stored in the Earth system, that's stored in the air next door. Let's imagine your neighbor just opened their oven and they're opening the window to vent the heat. Then you will
Okay,
feel
so
the hot heat.
that's a new tech. Actually, that's third approach, isn't it? That's what those people do who are trying this. What do you call it? Cirrus cloud thinning is poking a hole in the blanket to let out some heat from the atmosphere, and that's what you're
Yes.
referring to now, right?
This is a surface material science-based version of that, which can do a much better job at achieving the same goal with a much stronger local cooling potential. So the cooling power that's achieved, depending on location, can range anywhere from 20 watt per meter squared up to 400 watt per meter squared. And that's very significant. That's more or less comparable in some cases to the total solar irradiation. So especially in high altitude and low humidity regions, this selective IR radiation can be comparably powerful in terms of the cooling power density compared to, say, 100% reflective silver mirror or 97% reflective silver mirror. So right now, the technology for the various material science is maturing sufficiently quickly that we think in the near future, like each so-called mirror reflector devices can both perform shortwave light reflection cooling and also active long-wave IR emission cooling from the same footprint. So that can significantly boost the local cooling power of each square foot or square meter of deployed surface cooling panels.
Oh boy! Now you understand all of this, and you got to help me, and it's kind of useful that I am scientifically illiterate because some of our viewers are too, and therefore if I'm really stupid, I'm helping them by asking dumb questions. So you're going to have to work at getting me clear about what you just said. How are you going to, you're developing new means of allowing from Earth, you do something that allows the heat to escape. You're poking a hole in the thing that keeps it is hot and allowing infrared to escape. Is that what you said? Do I get it?
Yeah, so maybe I'll give a few examples of so people are on the same page as to what infrared radiation is. So imagine you're in your I guess a Christmas and you're in your family house sitting by the fire. You can feel the heat, the radiation from the fireplace.
Yeah.
If you close your eyes and just turn your hand, you can feel the heat on each side of your palm.
Mhm.
Similarly, you can also go close to your radiator in the winter and you can feel that heat. That is thermal energy that's radiated in these several micron wavelengths. So that's very similar to what any surface on Earth is putting out, but towards up into space all the time. So that's called the radiation. And there are ways to modify such radiation, one of which could be like these space blanket. When somebody is suffering from hypothermia, the intervention is trying to reduce how much further heat is escaping from the patient's body. So you want to wrap the patient into a material, a surface, which does not allow for radiation of this heat. Hence you have the metallic coated space blanket. So this metal surface has what's called a thermal emissivity of 0.2 to 0.3, which is much lower than, say, that of a puddle of water, which can be very close to 100%. So meaning that if the person is at, say, 36 degrees Celsius, and there's a bottle of water that's at body temperature. Heat will escape from a space blank covered body at only 30–20% the rate as heat escaping from a open puddle of water or from your skin. So one can definitely modify the thermal radiative property of surfaces. So that's a very crude explanation using only one number, which is called the emissivity, which itself is a integral of the emission wavelength speed, specific emission at different wavelengths. So you can imagine if you're a snake, you can probably, I don't know how a snake sees, but they can probably see different infrared lights as we can see blue, yellow. And there are different hues of radiation from your radiator. So you can imagine that for greenhouse gas, let's imagine we can see IR, and let's say CO2 is yellow and water is blue.
Okay.
Then you would see a mixture of those, like that would go purple. You would see a purple atmosphere. But then, say the color red
I think it would be
or
green.
UV can still pass through. So if you shoot the laser, which is red, which doesn't interact with this, sorry, I think absorption, call it inverted, but anyways, you get the idea. So you can selectively choose a wavelength that doesn't interact with water or CO2, and that wavelength will escape unhindered into space. So the engineering question is, can you modify the chemistry or composition or structure of the surface such that whatever radiation is coming out of it is able to not be subject to the greenhouse gas effect? Hence, they're able to directly go through the atmosphere and provide a shortcut for heat to leak into space, rather than have to take this circuitous route by interacting with all the water molecule zigzagging before they finally can leave.
Okay.
So-
I think I'm getting a little bit. Go on. This is new to me.
It's like
Yeah,
you have
but-
a sink and water
this-
is trying to escape, which is clogged by greenhouse gases. Now you're creating a new leakage port, a new sink.
Huh?
Yes,
Which is clean.
yeah, is going into a lot of detail about a very new technology, which is extremely promising to address the thermal side, but we've got a very severe problem on the reflectivity side. We've lost a huge amount of snow and ice cover in the Arctic. The Arctic is warming, and the amount of energy that's coming in as a result of that is huge. It's many times more than the entire energy consumption of humanity.
And
Ten-
that I'm aware of.
yeah,
What he's been telling me is really alien to me. Now,
Yeah.
you understand him, right,
Yeah.
John? You work on me because I'm not an easy student on these matters. So I'm only getting a glimmer of what he's talking about. So see if you can help him work on me.
well, I think we're getting rather off our topic, and I'm rather
No,
conscious we've only got
no.
10
I-
minutes to go.
Oh dear, that's right. Well, okay.
So
I'm really at a loss.
can I say that I'm enthusiastic for Ye Tao on this new technology, but we have a very short-term problem with the Arctic, because the
Yeah.
Arctic is melting away. It's in meltdown, and the meltdown includes the Greenland ice sheet, which has can produce 7 meters of sea level rise if it melts. So we've got to stop that, and to stop it, we've got to stop the Arctic warming. And to stop the Arctic warming, we have to remove energy from it faster than the energy is being put in. And because so much sea ice has disappeared and so much snow has melted, there's so much retreat of the sea ice and the snow that the sun is getting absorbed sunshine into the Arctic, It's absorbing a huge amount of energy. We've got to get rid of that energy very quickly. Otherwise, we're going to be committed to a continued warming in the Arctic, and that's a commitment to 7 meters of sea level rise. So just from Greenland alone, let alone some effects on the Antarctic happening at the same time. So,
And SAI is your preferred method of doing that.
yeah, I think it's the only method that can produce in a short time a huge amount of cooling.
It's Herb,
Enough.
you've got an angle. What is your thought?
Well, I just like to say that at HPAC, which was mentioned earlier, our organization, Healthy Planet Action Coalition, we've been discussing and debating these issues for 3 years now with people like Ye and John and many others who are incredibly innovative and knowledgeable about the ideas. And the challenge is that we need to raise the debate or the discussion, I'll use that term, discussion, that's occurring here and in our forums and in other places to the global level. And not just have it at this level that we are. What we're proposing at HPAC or saying needs to happen is that the world community in some forum, it could be at the Council of the Parties, at COPs, it could be at the G20, it could be at the UN environmental meetings and other opportunities, needs to basically do an objective assessment that goes well beyond what the IPCC demonstrates or concludes as to how bad the problem is. Most of us think we're on life support and we're in danger of crossing irreversible tipping points that we may have even already crossed, and therefore we need dramatic interventions. But what we're saying is the world community needs to evaluate as rapidly, as objectively, and as equitably as possible the SAIs and the marine cloud brightenings and the mirrors and the ocean iron fertilizations. And as Ye mentioned, we produced a paper describing briefly 15 or 16 approaches, and there are probably many others and many variations. The problem is that this kind of discussion is not happening at the world community, and and there's almost no social acceptance for the kinds of interventions that are planetary or large scale, as opposed to the localized interventions that Ye is perfecting in Freetown and other places around the planet right now. So there's an enormous amount of institutional and political and public engagement that needs to occur in order for the kinds of perspectives that John has been tirelessly advocating for years to be heard at the highest levels and evaluated.
Well, I can't get it heard at the highest levels. My task is just to make it clear at this little bitty, forum, what is, clarify something. Now, it feels like I wanted to talk about SAI, but when we start talking about that, we find that we need to look at some other things. And Ye has broached these other things, but it takes us off course. Does it or not? Do we need to talk about what Ye has been mentioning as a way of allowing more infrared radiation to leave the planet? That sounds good to me, but is that relevant and essential to our discussion of SAI? Ye, what do you think?
I think we can leave the technical specificities aside. Everybody here agrees that cooling as quickly as possible on a massive scale is needed. And very quickly, the conversation or calculus becomes one of ethics rather than scientific specifics, not least of which is because we do not currently have the instruments, the network to really do proper science on these geo experiments. So now let's just assume that somehow, hopefully, we'll be able to institute such monitoring networks to be able to do the proper assessment once the global community had come to the same realization as HPAC has. But now let's just think about the ethical implications of various such interventions. I think it's pretty accepted that any such large-scale intervention you perform globally will have varying impacts at different regional level, local levels. There will be winners or losers, so to speak. So I like to invoke the analogy of a conductor of a train on a train that's en route to crushing 5 people tied to the track. And you are a track switch person who can divert the train to another track where only 1 person is tied. So the question is, should you put the lever or not? Because we are effectively on that train and we're about to induce massive hunger, massive death from drought, displacement, as is happening today in Nigeria, right? 2 million people displaced, and many people being killed currently in the different several hurricanes happening globally, 2 of which in the region that I'm currently in the not too, this week and 2 weeks ago. So people are already being killed by extreme weather events. So we are en route to crushing those factors. More likely than not, in the near term of these massive cooling interventions, we probably induce more favorable conditions in more locations than others, but there will be losers. So the losers, maybe the state of Wisconsin, let's say, people there will die, will be starving. So they are the 1 person that we choose to sacrifice for that intervention. So should we do that? So that's the problem of ethics. Of course, those questions can be better understood and debated properly if we have the monitoring network and computational capability to project, to predict, to really understand what can be attributed to our active intervention and what's a legacy of the past failed geo-experiment, right?
Okay,
So,
well, again, I have a feeling you've introduced something very important, but it doesn't help me today wind this up in something like 10 minutes, saying, yes, SAI is a good way to go or not. And that is
we don't know. The answer is we don't know. We cannot know because we do not have the tools to really study it. Proponents
John,
of SAI.
you and Herb agree with him that the reason we can't reach a conclusion about SAI today is we don't have the tools. I mean, I never heard anybody say that before. People argue all the time about SAI and on all kinds of grounds, but I never heard that we really, in principle, can't answer it now because we don't have the measurements. Is that?
We can do a first order
I think we
assessment.
have enough measurements of the Arctic, of the amount of heat being extra heat being absorbed in the Arctic. We've got enough measurements to be able to estimate the amount of heat, and I've asked lots of people for estimates, and I've got a kind of conclusion for the energy range and the amount of cooling power to start lowering the Arctic temperature, because it's heating. There's so much energy coming in, extra energy. We've got to get rid of a huge amount. And the only technology that can do it, as far as I can tell at the moment, is stratospheric aerosol injection. And if we don't start lowering the temperature, it may become impossible because things are getting worse. So we've got to start lowering the temperature, and then the various tipping points in the Arctic will start. Will also halt. The Greenland ice sheet will stop melting away, and we'll save ourselves from catastrophic sea level rise and probably even more extreme weather, because
I think everybody that has listened to any number of these forums with me will agree to this proposition that, and this is maybe against what Ye is saying. I think we would all agree that the emergency, that the heating of the poles is so extreme and urgent, and that we cannot wait to do all of the counting, all of the monitoring, all the scientific experimentation that would normally be done before carrying out an engineering project. The engineers would want to know a lot more than we can provide. But when you've got an emergency, you do what you got. You use whatever you have, even if you're not sure that it's any good. And I think that most of the people listening to this series of shows would now come to the conclusion that we are in that kind of emergency, and that therefore we cannot take the time to do the kind of monitoring that you wants. Now tell me I'm wrong. Yeah, you can argue with me, or anybody can.
I
agree
can be
that,
agreeing
we
with you. I agree with you.
So I agree that it's an emergency, and I can truly understand why people have that feeling. It's an act out of desperation. So I think we should call it geo experiment from now on, because it's a shot in the dark with our eyes blindfolded. We're just trying our luck. The situation, as you make it sound, is so dire that it's worth trying anything. It's like you have cancer, you're just willing to try the newest concept remedy. So that's certainly understandable from psychological point that people wanting to survive.
That is different.
However,
the next step is, if you agree that that's true, is that sufficient? Is there enough evidence now to say, and say SAI is the way to go, or one of the ways to go? We can take the risk of using something we don't know enough about in the case of SAI to start it.
I think that's not the right next question. The right next question for humanity is, what's our vision for the future? What's our vision for our children, for our grandchildren? We wish our grandchildren to still have the option of choosing where the future, how it evolves. What's our vision for civilization 200 years from now? And once we start this SII intervention, we would be more than likely locked into having to deploy it over century timescales, even if we were somehow able to achieve carbon neutrality, because that's the timescale for the residual legacy field to greenhouse gases to decay.
Let's go back to the emergency argument then, because if it's really an emergency, what that means is, if you don't act now, you're not going to have any grandchildren. There's nothing going to be around for your grandchildren. So forget that. Do what you got to do right now just to make sure you have anything left for your grandchildren, whatever.
Yeah, so then we want you to try the safe way, which is to perform the intervention by prioritizing saving the human habitat in ways that we do not cause massive harm. We have experienced modifying planet's surface over the past few hundred to thousands of years. We have lightened the color of the ground by 0.12 watt per meter squared, which is already 10% of what's needed by interventions such as MIR to deliver stabilization of the climate for the remaining.
How did we lighten by cutting the trees? Is that how we?
Yes, by cutting trees. Yes, exactly. When we transform forests.
Goody. Hot diggity. That's wonderful. Now that's terrible.
So that's unfortunate, but apparently, if you cut
now
trees,
we're getting around now to your thing, and we don't have more than about 2 minutes to do it. You want us to put mirrors on our houses, and that will do it. Is that what you're saying? And
no, that's not that easy. So what we are proposing is to couple the cooling intervention to necessities for everyday life, which includes shelter, access to free and safe fresh water, drinking water, and also water for irrigation purposes, and to safeguard our crop fields from scorching heat. For example, Japan is not able to get rice. The Japanese family haven't been able to buy rice for about a month or so, because the stock from the year and last year the yields were very low because of extreme heat. So if we perform local cooling using these reflectors in the agricultural setting, then we can perform two functions at the same time. We can increase the resilience of our agricultural food system and at the same time achieve regional scale and eventually global scale cooling as a side unintended benefit to these local adaptation necessities. And there's also new kinds of films that are able to reflect away the near infrared light and also the green color and UV, which are not photosynthetically active, but only let through the red and blue light, which drive photosynthesis. So one can use these new materials to achieve both functions and often inducing increase in per acre yields in crops and fruits and vegetables.
This conversation does what good science is supposed to do. That is, if you begin to try to answer one question, you open up a whole bunch of new questions and you just multiply your problem set. And I think this conversation has multiplied the number of question marks in my head beyond the ones that I really want to have there. I'd like to get a few of them removed, but we've added some question marks. Now the question is, we're at the end of a conversation. Can we plan to continue this or do another step 2 in this exploration? I don't know where to go with this because I don't think we have solved anything here, but that's not bad. That's good sometimes, because if you at least get more clarity about a range of other problems, it's good. But you sure haven't got me satisfied that I now know what to do, and nor can I expect my listeners to. Where are we going to go with this? I can schedule another program if we think we can make any progress, or are we going to go off in all directions and just keep multiplying the question marks? John, what do you think?
Well, I think it's very straightforward. We have a crisis, and the worst aspect of the crisis is what's happening in the Arctic. The Arctic tipping points, so-called, are already activated. If they're allowed to continue, they'll get to a point of no return, where whatever you do, you won't be able to stop them. And we're very near that point in the Arctic as a whole. If we don't start cooling it, it will just continue, the temperature will just continue to rise. You'll get complete meltdown. All the permafrost will thaw and produce methane, more greenhouse gases, and
okay, we got that.
And the sea level rise. I mean, we will get committed to 7 meters, probably much more than 7 meters, because of what's happening in the Antarctic, if we don't cool. And there's now, we have research papers that suggest that SAI can cool the Arctic.
All right. Let's assume that everybody agrees that SAI probably can do it. There may be some risks. There probably are some risks. The question is, do we go with Ye, who I think just wants us to explore a lot of other things that are going to take time? And is that what we're up against right now? The question of whether we're going to advocate, we should advocate starting to work with things like SAI and maybe even the mirrors. I have nothing against mirrors. I wouldn't have any clue how to do it, but any of those things, let's get going. Or should we just go on trying to capture more data so that our grandchildren will have more information if they manage to survive? Is that the issue we need to decide before about 30 seconds? I'm going to turn off this show.
I don't think it's a time for advocacy. It's too early for advocate one method over the other or vice versa. I think we need to expand the conversation to what are the root causes of our predicament. SAI can mask the problem produced by fossil fuel consumption, but fossil fuel consumption is not a primary cause. It itself a consequence of the capitalistic system,
Oh,
having
good.
found a
Now
cheap
we got
source
to
of energy.
I'm sorry, Ye.
Yes.
Now you've really lost me. We are not going to have a communist revolution before we can get the, please.
No,
No.
we're not having a revolution
Now,
to solve the problem.
this is not the conversation about overthrowing capitalism, for Pete's sake. It might be a question of if we don't do these experiments and monitor stuff enough, we may be in grave difficulty by implementing something like SAI. That is a conversation that we could still have, although we don't have any time left for it. But I think the answer that maybe that I think John and I would agree to, maybe Herb and I don't know about Kathy. I think I am ready to say this is really an emergency. Let's start doing real things, even if they're risky, because we've got to do something quick.
Well, let me
And-
just say,
yeah.
number one, you cannot, there's no social acceptance or political acceptance to do large scale SAI. In fact, you had the smallest, most modest experiment recommended by Harvard folks in Sweden called ScopeX in 2018, a couple kilograms of sulfur, and the local indigenous people basically killed it, and it's yet to occur. So all I'm saying is that I'll just sort of reiterate what I said earlier. To me, the fundamental question is, how do we develop the social and political acceptance to get the world community to listen seriously to people like John and Ye and all the others who are recommending these critical issues that do need more research? Because we can talk all we want, and I'm not suggesting that a discussion that excludes that topic, it would not be important, but that's the fundamental constraint.
You're right. Well, we will be having at
Yeah.
least one and probably several more conversations among folks like HPAC people and Ye and anybody else who wants in on the conversation. We will be having conversations specifically about how do we get public opinion to be rational, because if we've got an emergency and people are denying it and are not interested in hearing anything about the major decisions that need to be made, then the problem is not in the technology. The problem is in people's heads. And we have
Exactly.
society turned around. I agree. I'm a
Exactly.
sociologist. I'm not a scientist. Obviously, from the stupid questions I ask, I'm not a scientist, but I am a sociologist. And there is a real problem for us. And I don't know that we have any good answers. But we do have some plans to have another conversation about it. Okay, guys, we've used up more than our time. And I'm more than pleased. Thank you very, very much. Are all of you willing to come back and give it another go sometime? Yes?
Yep.
All
Yeah,
right.
sure.
Thank you. Okay,
Yes,
appreciate it. We got to quit now.
Thank you,
Mike.
Meta.
Thank you.
Thank you.
You're a
Thank
great
you.
host.
It's wonderful
I
to
really
talk to you.
appreciate the opportunity and good to see John and Ye. Last time I saw John was sitting in his living room in June having a lovely cup of tea in Bath, England.
All right. Take care, fellas.